We're not dealing with a linear equation. You can tell because the x is now squared. So what type of function has an x value that's squared, and that's a quadratic. Okay, so I'm going to talk about the three main different ways that a quadratic can be written. You'll see it in this class. So this first one right here, this is a standard form. Okay, so standard form will have an a value. Okay, and the y will be by itself. All of these have the y by itself. Okay, but what's unique about this is standard form. There's no parentheses. Okay, so this standard form, no parentheses. This is vertex form. Over here, vertex form has parentheses, but it's a binomial squared. And then over here, this is factored form. Factored form is when you just have two linear factors. So these are a degree of 1. All right, and then the next thing over on this column, these are all the best ways to solve a quadratic. Up here, this is factoring using the x. This is completing the square. And then down here, this is a quadratic formula, which always works. So I also have this worksheet connected attached as well. So the 5 ways to solve a quadratic. These are the 5 ways you can solve a quadratic. The x being the best and easiest method, but only works 90% of the time. Quadratic formula always works. So these are probably your top 2. And then here's another method as well. We have solving by just taking the square root, completing the square, and then solve by graphing. Okay, but let's go back to what we're looking at. So a right here, if the a term tells you if it's a quadratic, basically a parabola, will open up in terms of the parabola, okay? And then if it's negative, that means that it opens down, okay? One other thing that we get from standard form is the c value, which is your y-intercept. Okay, over here, the vertex form, we still get the a. So a tells us if it opens up or if it opens down. And then right here, the h and the k, that gives us our vertex. H and k is the vertex. Factored form, we can still see the a. Notice all 3 of these forms gives us tells us if it's opening up or down. Okay, so a, up or down. And then the last thing that it gives us is our x-intercepts, okay? And you could quickly find the y-intercept, I'd argue, with factored form, okay, as well. So what we're going to do is we're going to go through the 3 different steps, or at least for standard form, and we're going to actually graph it on this, okay? So let me pull this up. I'm going to move down a little bit. Okay, so in order to graph in standard form, you need to first find the axis of symmetry. This is the formula for finding axis of symmetry. See how it has a B and an A? Well, if we were to go back up to right here, our form, we have A and we have B and we have C. Okay, so we're talking about B, the term that's with the x, and the A, that's the term that's with the x squared. So let's look at this example down here. All right, let's label A, B, and C. So I know that this is my B term right here, and this is my A term, and then this is my C. Great. Okay, so it wants me to do this. So I'm going to take this and equal this. I have to take the opposite of the B term, and the B term here is 4. All right, we're working good. And then we got 2 times my A term, and my A term here is -2. I'll put -2 right there. All right, so let's simplify this. We've got -4 up top and -4 on the bottom. A negative divided by a negative would be a positive, so we have +1. So my axis of symmetry is going to be at +1. So I'm going to go ahead and put a line that goes like this. Okay, now remember with things that are symmetric, a parabola is symmetric because one side looks like the other. So we're going to use that to our advantage, where if we just are able to find one side, we could just reflect it over this axis of symmetry. That's the benefit. Okay. Let's see. Next it says find the vertex. Well, we know that the vertex has to be on the axis of symmetry. All right, so we have, it looks like our x value is going to be 1. Now, how do we find the y value? Now, like earlier, if we have one of the parts of the ordered pair, we could figure out what the other is by just substituting it in. So here, where I see an x, I'm going to put a 1. Over here, I'm going to put a 1. And then just go ahead and simplify this. So I have -2, and that's squared. Then I have 4, I'm adding that, and then +6. So let's simplify. That's 1 squared, which is 1 times -2, that'd be -2. And then 4 times 1, that'd be +4, and then +6. So 4 and 6 is 10, and then that would give me 8. So my vertex would be 8, 1, 8. So from here, 1, and I go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, here's my vertex right here. All right, now do you remember if this parabola, this example right here, is going to be opening up or down? I'm going to erase some of this stuff. All right, so, and I erase my vertex. There it is. Okay. Yeah, remember the A value tells us if it's going to be opening up or opening down. So since it's negative, this means it's going to be opening down. So we know it's going to be going down like this in this general region. So a quick way to graph this is now we're going to look at our y-intercept. And our y-intercept is going to be this C right here, our 6. So y-intercept, if I go up 6, would be right there. Okay, so I know that my parabola is going to be opening down, pass through my y-intercept, and then come down like this. Okay, now all we're going to do is just reflect that point. So this gets reflected over here, and then I reflect the parabola that I started to draw right there. Boom. And that's how you graph in standard form for a quadratic. All right, so next what we're going to do is we're going to look at vertex form. And vertex form, obviously it's going to give us a vertex. So first thing we're going to do is we're going to plot the vertex, and then we're going to use the A as a slope. Now you got to be careful with using the word slope with quadratic because it doesn't technically have a slope, but the first value from the vertex, you can use it as a slope. So I'll show you what I mean there, okay? Yeah, see how it says first point. All right, so here our vertex is going to be the opposite of what's inside the parentheses, so the H, so that'll be positive 1, and then whatever this value is, positive or negative. So this is positive, so it's going to be positive 8, okay? So we have an ordered pair, which is our vertex. Remember, that's that point of our parabola, 1, 8. And then we're going to use this as a slope, like a rise over run. So our slope for our first point, okay, I can't stress enough that it's only for our first point. Okay, the slope for our first point is going to be -2/1, and we're going to do that in both directions. So let's plot our vertex first, which is 1, and then going up 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our vertex, and then our slope is going to be going down 2/1. So I go down 2, back 1 as well. Okay. Now we have our 3 points, and now we know that our parabola is going to be passing through those points, coming down, passing through this point over on this side, coming down. And that's how you graph in vertex form. Really quick and easy. All right. So the last form that we're going to be looking at is factored form. So notice factored form has these two factors, okay? So we can also find our y-intercept. So it says set each factor equal to 0. And basically what we're doing is we're finding the x-intercepts, okay? And then we're going to use our A to tell whether it's going to be opening up or down, okay? And then lastly we can plot the y-intercept. So x plus 1, so I'm going to take x plus 1 and I'm going to set that equal to 0. If I set that equal to 0 and then solve for x, I'm going to subtract 1 from either side. So I know that one of my x-intercepts is going to be at +1. So I go ahead and put that point. So at +1, I have a point. Okay. And then let's do the next one. So we have x minus 3. So I'm going to write x minus 3 equals 0. And then I solve. So I add 3 to both sides. And then when we clean this up, we get x equals positive. Oh, did I? Shoot, I made a mistake. Hold on a second. That should be at -1. There you go. And then that one's at +3. So 1, 2, 3. Here we go. All right. There you go. -1. I forgot to put that negative there. All right. So we know that it's going to pass through this. We know our A value. Since it's negative for this one, it's going to be passing through and it's going to be going down. Okay. And then our y-intercept here in this case, we can figure out what our y-intercept is by multiplying this value times this value times that. So here we have -3 times 1, that'd be -3 times -2, which would be +6. So y-intercept is going to be at 0, +6. So 1, 2, 3, 4, 5, 6. Bam. Since it's not in the middle, that means that's not going to be where our vertex is. So what I'm going to do is I'm going to pass through this point right here, come up, just go a little bit past it, and then go down. All right, so in short, when you're graphing these three different forms, I want you guys to understand that we didn't really know where it crossed the x-axis. We just kind of followed the line, okay? So in standard form, that's not really going to help us identify where the x-intercepts are, okay? So let's look at this. Factored form is where it tells us the x-intercepts. Okay, and then our vertex, we didn't really know what our vertex was in factored form. You know, we just kind of looped it around. So then if we want to know our vertex, obviously vertex form would be the best the best choice. Now, this one you were able to find the y-intercept, but standard form was the one that gave us the y-intercept like without doing any work. Okay, so let's take this information that we just learned and let's see if we can try to solve this release question for a standardized test. I'll read it. So it says f of x, g of x, and h of x are shown below. Here's f, g, and h. And we see all the different forms. We know that they're quadratic because it's squared. It says match the three functions with their graphs. Okay, so here, let's see if we can identify what the three different functions are based upon the notes that we just took on that previous slide. So we see that top one there, we see it has parentheses and it's a binomial that's squared. So if it's a binomial that's squared, that means that we're looking at vertex form. Okay, so this one right here is vertex form. All right, and then this one right here, it has squared, it has no parentheses, so this is standard form. Okay, and then this right here has two distinct factors, so this would be factored form. All right, so now we have the three forms. Now we got to try to match it. All right, so looking at this, when it comes to vertex form, the easiest thing that we can find is the vertex. So remember with this, we take the opposite, which would be negative 1.3, and then we take whatever this is, we take whatever that is, which is 1.18. So that would be our vertex for f of x. So that means it's negative and then positive. So it's negative x value and then a positive y value. See, so the only one that could be, because all of these have a vertex in different quadrants, okay, that has to be a. So I know for sure, based upon my information that I learned, that f of x has to be the a graph. Okay, now looking at the next one, g of x, we see that it has a y-intercept of positive 3. So let's see, this one, this one. Okay, so look, it's not a, we just figured that out, so it has to be this one right here. But maybe we made a mistake with a, so we're going to just keep going. Okay, so we're going to say, though, that g of x is c. Now here we have factored form. Now remember, with the factored form, we want to make sure that we take each of these factors and set them equal to 0. So if I was to set this equal to 0, I'd have to add 1.5 to the other side. So that means I have one x-intercept that's going to be at 1.5, and then I have another x-intercept. If I subtract this, that'd be at negative 1.2. So I have a positive x-intercept and a negative x-intercept. So if we look here, a doesn't even cross the x-axis. C only crosses the x-axis on the positive side, and B is the only one that crosses on the negative side and on the positive side. So B has to be this guy. So we were right about A. All right, there you go.